All right, let's look at the scalar potential. All right, the good example would be a force of gravity, and the force of gravity is a conservative field. You can double check that. If you take the curl of the force of gravity, it's pushing downward. So x component and the y components are 0, and the z component would be negative mass times acceleration by gravity. And you can double check that if you take the curl of this guy, it's going to be 0, right? So which tells you that this field is conservative, right? When you have a conservative field, there's something called a scalar potential we can find for this particular force field. Right, so let's try to find that. So scalar potential is, in this case, is going to be phi, right, which is going to be simply mgz, right? And you can see that this scalar potential, if you take the gradient of this phi, you would get, let's see, so partial with respect to z, x would be 0, partial with respect to y would be 0, and the partial with respect to z would be, mg, right? So you notice that if you take the gradient of this scalar potential, it's going to be the negative of the original function, original force field. So F is exactly the same as negative of the scalar potential, right? And we can do this with any conservative field. For example, so let's look at the kind of a random force field, F, 1 comma negative z comma negative y. Right, so we can double check that this is a conservative field, so take the curl and it's going to turn out to be 0 vector, right? So this is conservative, right? Conservative, right? Let's try to find the scalar potential, right? So we know that we want, let's see, gradient of phi, which is partial of, let's say, phi with respect to x, comma, partial of phi with respect to y, and a partial of phi with respect to z. And we want this guy to be negative of this force field, so it's going to be negative 1, z, and a y, right? Then we're going to start with try to find phi from here. So since partial with respect to x is going to be negative 1, so we can actually find it by take negative 1 and take the antiderivative of this, then you will get negative x, right? But plus some constant, but you can see that this is a partial integration or a partial derivative with respect to x. So any other letters except for x will be considered to be constant. So you might have a function of, so I'm going to call it probably g, a function of y and z, right? So we know this much. So, but again, we don't know what this guy is yet. So this is the question mark there. All right. So we can use other clues. So since the partial of this phi with respect to y is going to be equal to, so a partial of negative x with respect to y is 0, and then it's going to be a partial of g with respect to y, right? And this is supposed to be equal to z, right? Right, from here, we can find that g is going to be, so this is going to be a function of y and z. We can simply take the z, then take the antiderivative with respect to y. So this is going to give us zy. then you have plus a function of z left, because z is considered to be a constant. All right, then we can use the last clue, so partial derivative of phi with respect to z. All right, so from here we get, let's see, zy, so it's going to be y. Then you have h prime of z. All right, then this is supposed to be equal to y here. So this tells you that h prime of z is equal to 0. Right? So which means that h of z is going to be some kind of constant. Right? So we can find a phi, so therefore phi is going to be equal to, right, so let's see, we know that it's going to be negative x. Right, then g function is zy, and h of z is just a constant, so plus some constant c. Right, so this is going to be a scalar potential. You can see that if you take the gradient of this guy, you get the negative of the original force field. Right, so we can find this scalar potential and for any conservative field, but the good example was force of gravity and scalar potential. You probably have noticed that this guy right here is really the in physics it's probably called the potential energy. Right. That's what the scalar potential is for force of gravity. Right? That's it. I hope that this was clear.